Why is it critical to grasp the complexities of fluid machinery and turbomachinery, you may ask? Well, these two mechanisms form the backbone of various industries, from power generation to aviation. Today, we delve into this fascinating world, breaking down its components and complexities. Our first segment focuses on the basic introduction of fluid machinery and turbomachinery, along with their applications. Fluid machinery, a broad category encompassing machines that use fluid to perform work, and turbomachinery, a subset of fluid machinery characterized by energy transfer between the machine and the fluid, are integral to many fields. Depending on their function, there are power-producing and power-absorbing machines, with further categorizations into axial and radial flow, single-stage and multi-stage, and thermal and hydro-turbo machines. We also delve into the concept of whirling of fluids and the fundamentals of hydropower generation. In the second segment, we turn our attention to turbine characteristics. Turbines, the heart of fluid machinery, can vary greatly in their design and function. We explore the performance characteristics of Kaplan-Francis turbine, along with the principles of impulse and reaction turbines. We also discuss the dynamics of wind turbines, positive displacement turbines, and the importance of governing, selection, and performance. Additional topics include the role of draft tubes and cavitation and the use of vanned diffusers. Our third segment focuses on pump characteristics. Pumps, like turbines, are a fundamental part of fluid machinery. We delve into the mechanics of reciprocating and rotary pumps, pump performance curves, and the challenge of matching a pump to a piping system. We also discuss pump cavitation and net positive suction head, along with the workings of dynamic pumps, centrifugal pumps, and axial pumps. In the fourth segment, we discuss the scaling laws of turbines and pumps. We explore dimensionless turbine parameters, turbine-specific speed, and dimensional analysis. We also delve into pump-specific speed and the affinity law, which provides a crucial understanding of how changes in speed and impeller diameter affect pump performance. Our final segment dives into the world of jet propulsion. We explore the theory and applications of jet propulsion, discussing pulse jet engines, ramjet engines, and scramjet engines. We also delve into the workings of rot dynamic machines and compressor characteristics, including reciprocating and rotary compressors. In summary, understanding fluid machinery and turbomachinery provides us with the knowledge to harness the power of fluids, whether it's to generate electricity, propel an aircraft, or pump water. From the basic principles of these machines to their specific characteristics and applications, we've taken a comprehensive look at this fascinating field. Remember, the world of fluid machinery and turbomachinery is vast and complex, and today we've only just scratched the surface.